So in this particular video, we have an object that is being shot upward at a rate of 30 meters per second from the top of a building that is 80 meters tall. All right, so the diagram here gives you a lot of information. So this is part one of two videos for this particular schematic. So I'll show you how to do a bunch of different parts based on what's being asked of you to calculate. All right, so let's knock out part A and B. Again, if you need to, pause the video or write the stuff down. Hopefully, keep along here. All right, part A and B. Part A asks you to find the instantaneous velocity at 1.8 seconds, so after it is launched. So I know that the final velocity function is acceleration times time plus the initial velocity. Here, the acceleration variable A just got replaced with G because G is acceleration due to gravity. So instead of writing A, we just write G for the word gravity. At the surface of the planet, here on Earth, it is accepted to be about negative 9.8 meters per second square. Okay, so therefore, we just substitute in values here. So G, I substitute in negative 9.8 meters per second square. Time is 1.8 seconds. So I'm going to plug in times 1.8, but I'm starting at 0 second. So therefore at 0 second, my initial velocity was given as 30 meters per second. So here I substitute in VI as 30 for that reason. So my time interval here is from 0 second to 1.8 seconds. Okay, so at 0 second, my initial velocity is a positive 30 meters per second as given in the statement and in the diagram. All right, so we simplify this on the calculator. Negative 9.8 times 1.8 is negative 17.64, and then we're going to add 30 to that. Therefore, simplifying this on our calculator, we should get a value of 12.36. Here, I've chosen to include the plus sign because it's still moving upward. And since it asks for instantaneous velocity, I know that I need to provide a direction. So here, I've just chosen to write the plus sign, or you can say 12.36 meters per second upward if you choose to. Okay, so that's my answer for part A. Pretty straightforward. Part B asks you to find the time that it takes to reach point B. So in order to do point B and to make it simplify, you first have to recognize that at point B, the instantaneous velocity is 0. Because for an object to change direction, it must first come to a stop at that moment in time. So it's V instantaneous at point B at the highest point of flight would have to be 0, and then it starts to fall back down. So that is an important condition to keep in mind as you practice these types of problems. Okay. All right. So to do part B, all I have to do is use the average acceleration equation. Average acceleration equation is just change in velocity over change in time. But the question here asks for how long, aka change in time. So to solve for delta t, I must do a little algebra manipulation here. I want to move the delta t to the left side because it needs to be in the numerator, but at the same time, I want to move the g down in the denominator on the right side. So therefore, change in time is change in velocity over gravity, or acceleration due to gravity. All right, and then we can expand delta v into vf minus vi divided by g. But here, I know that my VF I can cross out because it asks for how long does it take to get to point B, point being the highest point of the upward motion. So therefore the final velocity at that point must be 0. I know my VI is 30, I know my G is negative 9.8, so I'm just going to plug in values. Here I've chosen to carry down the negative sign in this function because that's part of the function. VI itself is a positive 30, and then G is negative 9.8 meters per second square. The negative sign here will cancel out, and if you do this, you should get about 3.06 seconds. So that is our time just to get to point B. Okay. All right, let's move on. Let's do part C. Part C asks you to calculate the maximum height that the ball reaches before it changes direction. So here in this diagram, it's ymax. So from where it was launched at the top of the building, aka point A, it's going to go all the way up to point B. So how high is that? It's easy to do. In order to do that, I think the easiest way to do this one is just to use this particular kinematics equation that is time independent. Okay. Now, why would I want to use this? Well, I want to use this because one, I know VF at point B is 0 because it says the highest value of H. I know my VI is 30. I know G is negative 9.8. So the only thing I don't know is delta Y, which is what the question is looking for. Okay. So therefore, I'm just going to do a little algebra manipulation here. To get delta Y by itself, I need to divide both sides by 2 and G. That's why the 2 and the G is now in the denominator on the left side of the equation. Well, I can now cross out VF because at point B, again, it is the highest point of the flight. So that is ymax. So at ymax, Vf is equal to 0. I'll cross that out. My Vi is given as 30. Okay, and then therefore, I just do a little plug and check. Vi is 30, G is negative 9.8, and then if you simplify all of that, you should get negative 900 in the numerator, and then negative 19.6 in the denominator, and then the negative signs once again cancels out. So this will leave us with a displacement of 45.9 meters. Since it asks for maximum height, I would just leave it because height is a scalar. So it moved upward 45.9 meters before it came to a stop and then turn around and fall down. Okay, so that is our answer for this one. It'd be 45.9 meters. Okay, all right. Now, if you wanted to, you can also find the maximum height using the displacement function here, which is delta y is equal to vi t plus 1/2 gt squared. Well, I know my vi. I don't know my time though, so if you want, you can just use this. It will just create a little bit more work for you, but it's okay. Here, I've chosen to plug in Vi as 30 because that's given to me. I don't know how much time it took to get to the peak. If you just attack this from scratch, of course, and then here the 1/2 is carried down. G I substituted for negative 9.8, and here's T, and then it's T squared. Okay, but if you pay attention to the previous two parts, delta time here to get to the peak is 3.06 seconds. So we already previously calculate that. So therefore, we can just use that value previously calculated and plug it into here. Okay. So it took about 3.06 seconds to get from the top of the building to the maximum height. And that is our time to get to ymax. So now that we know 3.06 from our previous calculation, we can substitute it in quickly. And then if you simplify all this on your calculator, you get 91.8 plus a negative 45.88. So here, if we add the positive and the negative value, we'll get a positive 45.9. So as you can see here, the answer comes out the same, 45.9, regardless of which strategy you exercise. Okay, but I think the other easy way to do is this function here, setting the two average velocity function equal to each other because acceleration is constant. In this problem, because acceleration is constant, this particular function is good to go. So your vertical displacement over your time is equal to Vf plus Vi, not minus, Vf plus Vi divided by 2. Again, these two functions come from the average velocity function, and we just set them equal to each other. All right, so to solve for delta y, let's go ahead and get rid of the delta t in the numerator by multiplying both sides by delta t. So delta y is simply Vf plus Vi divided by 2 times time. Well, I know what my Vf is because I'm looking for ymax. At ymax, my final velocity is a 0, so I'm going to cross that out. I know my Vi here is 30, and I know my change in time as previously calculated is 3.06. So if I plug all that in, I have 30 divided by 2, which is 15, and then 15 times 3.06 will give you the same value of 45.9. So here are 3 different strategies. Pick one. Make sure you execute properly, make sure you write your functions out correctly, and it should give you the same outcome. All right, let's do part D. Part D asks you to find the average velocity during the second. So here is terminology that you should hopefully by now be familiar with. Second implies that the time interval is from 1 to 2 seconds. Okay, so let's go ahead and attack this. The definition for average velocity is displacement over time. So instead of delta x here, I've just written delta y because now we're just dealing with the vertical direction. So it's that easy. Replace the variable x to a y, and the change in time stays the same. All right. Now to solve for average velocity using this strategy, you need 2 things. You need your delta y and your delta t. But we know what our delta t is already. The statement said the second. So it's important for you to understand that this is not 2 seconds. This is actually just 1 second. The second starts at 1 second and it ends at 2 seconds. So from 1 to 2 seconds is just a window of 1 second or an interval of 1 second. Okay. Common mistake is that folks would put 2 seconds here, and I'm like, it's not. It's just during the second, suggesting that it starts at 1 and it ends at 2 seconds. So that's important. All right, so therefore we know our change in time here is simply just 1 second because 2 minus 1 is 1, okay? So I just went ahead and replaced my change in time for 1 second. I don't know what my vertical displacement is during this time, so I'm just gonna go find it. To find my vertical displacement, I can just use the displacement function here, and then I can just substitute in t being 1, 9.8 or negative 9.8 for g, and then again t's 1 here. However, I don't know what my VI is, okay? And this is usually where folks who are new at this might want to put in 30. VI is not 30, okay? VI is not 30 because this particular question starts at 1 second. So it's important for you to differentiate initial velocity based on what the question is looking for. That's a common mistake that people do, is that they put in VI is 30 because the diagram shows VI is 30. But VI is only 30 at times equal to 0. This part here starts at 1 second and ends at 2. So your initial is 1 second, your final velocity is at 2 seconds. All right. So therefore, let's crank this out. This strategy is super easy to do. Okay. I think when you're given an initial velocity, whether it's being shot down or up, in the vertical direction is super easy. Whatever the value to start is, you keep subtracting 9.8 because the value for acceleration due to gravity is negative 9.8 meters per second squared. So it's telling you to minus 9.8 every second. So here at time equal to 0, the problem says that it's moving at 30 meters per second upward. 1 second later, it slows down by 9.8, which now gives me a new velocity of 20.8. Again, these are all positive values here. Okay, I didn't put the positive sign because I'm just looking at the values here. But if you want, you can feel free to put the positive sign in front of these values. And then another second goes by, it slows down by another 9.8. So as you can see, I'm just subtracting 9.8 here. And then when I take 10.4, subtract 9.8, that'll give me a value of 0.6. And then how fast is it moving at 4 seconds? It's now actually in the opposite direction. So it's turning around, which makes sense because earlier we calculated the time that it took to get to point B was only 3.06. Well, 4 seconds would imply that it's more time. So now it's on its way down. Well, how fast is it moving at exactly 4 seconds? Its instantaneous velocity at 4 seconds is negative 9.2. And I want to take that value. I'm going to subtract another negative 9.8, which now gives me a negative 19. And I'm going to stop here at 5 seconds because one of the parts I asked, if you need to rewind the video, is at times to go to 5 seconds. So I'm just going to take advantage here and just label all my velocities all the way up to 5 seconds. Okay, you can keep going if you like, but I'm going to stop at 5 because the time interval I asked in one of the parts stops at 5 seconds. All right, so therefore, I'm just going to box that. Now, I'm boxing that because this problem starts at 1 second. So my velocity at 1 second is 20.2. I want to substitute in for my velocity there. Therefore, my initial velocity for this particular part is 20.2 meters per second. So if I simplify all this on my calculator, I'll get a value of 20.2 minus 4.9. Okay, because negative 4.9 times 1 is just negative 4.9. And that will give me a displacement of 15.3. All right. Therefore, I can just replace my average velocity function here for wherever delta y is. I can replace it with 15.3. And that's where the 15.3 in the numerator comes from. And again, the denominator is simply 1 second because the time interval is from 1 to 2, which is a difference of 1 second. So as you can see, 15.3 divided by 1 is simply 15.3. Here, I've chosen to include the direction because it asked for average velocity and it didn't use the word magnitude. So therefore, velocity is a vector, which I will put a plus sign. Or again, you can say 15.3 meters per second upward shall you choose. Okay. Now, so that's that. Okay. However, if you can list all of these velocities quickly on your scratch paper, or you can mentally calculate these quickly using the VF equals GT plus VI function, it's super easy to do. Average velocity can be calculated under constant acceleration by using VF plus VI divided by 2. Well, what's my VF here and what's my VI? Well, as I discussed, my initial velocity, it starts at 1 second. My final velocity ends at 2 seconds. So I'm just going to box 2 seconds because that's the interval in which it is asking. Okay. So therefore, my final velocity is 10.4. My initial is 20.2. So if I plug this in, my final velocity is 10.4. My initial velocity is 20.2. I'm going to sum that up, divided by 2. So if I do that, the numerator gives me 30.6 meters per second. I'm going to divide it by 2. Therefore, it gives me also the same value, 15.3. Again, the plus sign is needed because it is velocity. Okay, so as you can see, if you have all of these values for velocity, which I think is a skill that's super easy to do, take whatever initial velocity is, just keep subtracting 9.8. Okay, and then use the velocity at the time that you're asked to solve for. And it's super quick to do. All right. So same answer. Okay. Part E asks you to calculate the average velocity during 0 to 5. As I mentioned earlier in part D, this is the time interval in which I was assessing. So it went up to 5 seconds. So all of my velocity here, I just stopped at 5 seconds for that reason. Okay. Now if a problem asks you at 6 seconds, so just keep subtracting another 9.8. All right. Here, calculate the average velocity during the from 0 to 5 seconds. So I'll approach it a couple different ways here for you again. Average velocity, again, is change in position over change in time, or your displacement over change in time. My vertical displacement, I don't know yet because it says from 0 to 5 seconds. I do know my time, though. My time is from 0 to 5, so therefore my change in time is just 5 seconds. I'm missing delta y, so I'll just go ahead and find delta y. Okay, to find delta y, super easy to do. Here, I can just use my displacement function again, except for this one. I know my time is 5. Okay, g is given as negative 9.8. My time is 5. Now, I left vi here as kind of an unknown here for now, just to show you it's important for you to pay attention to the initial velocity, the initial condition in each of these parts. Here, it says from 0 second to 5 seconds. So at 0 second, if you read the problem carefully, if you know how to do this particular chart on the right side, that hopefully I encourage you to do. At time equal to 0, my velocity is 30. So vi here would be 30. Okay. Excuse me. Therefore, if I substitute in vi being 30, if you simplify all this, 30 times 5 is 150, and then negative 4.9 times 5 squared, which is 25, will give you negative 122.5. And if you take the difference here, we have 150 minus 122.5. You should get a positive 27.5. And it's our vertical displacement. All right, so our vertical displacement can be substituted for 27.5. Our time here is 5 seconds, so I'll just substitute that in. And if we simplify this on our calculator, we should get 5.5, and it'll be positive. So therefore, our answer is 5.5 meters per second upward. All right. Now, once you have all this again, label out for you, where I'm circling back and forth, okay, well, I would just box, again, the velocity at the 2 points of time. Here, my initial time is 0, my final time is 5. So I've already boxed my velocity at 0 second, which is 30 meters per second. I want to go down, I want to go box 5 seconds. At 5 seconds, it's on its way down. It's traveling downward. So therefore, the velocity here is negative 19 meters per second. So my VF here is going to be negative 19. My VI is going to be 30. So therefore, I'll just substitute in. My VF is negative 19. My VI is 30. Negative 19 plus 30 is going to be a positive 11. And then 11 divided by 2 would just give you an answer of 5.5, which again is the same answer as on the left side of the screen here. Okay, so that's that. So I like this strategy a lot, assuming you can list out all your velocities, carefully without any hiccups. All right, let's do part F. Part F asks for the ball's average speed for the entire motion. So this one's a little harder to do. This one takes a bit more thinking. All right, so to find average speed, all we need is distance over time, total distance over total time. Okay, so let's go find this. We kind of know the distance already. Okay, so I'm going to remind you what we calculated in the beginning of the video. Okay, we've calculated this length here, ymax. How high did it go to point B before it turned around? We found this distance to be 45.9 meters. Therefore, once it stopped, it turns around and it's going to have to fall back down. So the second red arrow would be the same distance. Well, if you travel 45 meters upward, to fall back to where you were, you would have to travel the same distance, which is an additional 45.9. Well, from here down to the floor, the diagram says that it's 80 meters. So my total distance would be 45.9 plus 45.9 plus 80, because distance is a scalar. It does not care whether you move upward or downward. You just add every step, every motion taken. All right, so upward is 45.9, and then you fell back down another 45.9, and you fell an additional 80, excuse me. So therefore, the total distance would just be the sum of these values. So here in the numerator, distance is just 45.9 plus 45.9 plus 80. So for distance, add up. Okay, I don't know what my time is though, so this is where the thinking part comes in. Well, I don't know what my total time is. but that's not too bad, okay? One, I like using quadratic, so hopefully you have quadratic in your calculator. If you do, I think what I'm about to do is super useful. If not, pay attention to the second strategy, okay? To find time, I can just use my displacement, okay? Delta y is equal to VIT plus 1/2 GT squared. Here, I know that it started at the top of the building and it traveled upward and then it fell all the way to the floor. But I want to remind you that delta y is independent of the path taken. All that it cares about is where did you start and where did you end. Well, according to this diagram, it started at the top of the building here and then it just fell down 80 meters. So by the time this particular motion finishes, the object is 80 meters below where it started. So therefore, my displacement is going to be a negative 80. So the sign here is super important, okay? That's negative because it's below where it started. My VI is 30 because that was given in the diagram. I don't know what T is. So I need to find the total time of flight because it asks for average speed for the whole entire motion. I know G is negative 9.8. I'm going to keep T as T squared because this is what I'm trying to find. Okay, so I'm going to simplify this. Here, I want to move this negative 80 to the right side because at this point, I realized that I need a quadratic calculator or quadratic, solver. Because I have a T square, I have a T, and I have a coefficient. So I'm going to set the whole function equal to 0. So therefore, I'm just going to move this negative to the right side, which becomes 80. I do apologize for my dog barking in the background. Okay. Apparently she is ferocious. All right. So therefore, we have 30t, negative 4.9t squared plus 80. I'm just going to clean it up a little bit and leave the units out here. And I'm going to rearrange it based on the highest exponent. So t squared is the highest exponent, and then it's a t, and then it's the coefficient. So it will be negative 4.9t squared. And this is a positive 30t, so I'm going to keep that as positive 30t. And then this is now a positive 80. So here, I realize that I have it in quadratic format, so therefore, I can just pull out my coefficients. My A is negative 4.9. My B is a positive 30, because there's a positive sign in front of it. My C is also a positive 80. So if I do that, I can just use a quadratic solver. So I'm going to exit the screen real quick, okay, and then show you. Excuse me. Hi. Where is my solver? Here we go. Here's my quadratic solver. My A is going to be negative 4.9. My B is 30, and then my C is a positive 80. And if I hit calculate, okay, notice here it's going to give us two values, a negative 2 and then an 8.13. Well, we're solving for time, so the negative value is kind of stupid. Okay, you can't go with that. So therefore, it's going to take about 8.13 seconds to cover the whole entire motion. All right, so let's go back to my stuff here. Okay. So I'm going to fast forward to what I got to. So once you have A, B, and C, again, if you have a quadratic solver in your calculator, this is pretty light work. You can just carry this work down. So here, 45.9 plus 45.9 plus 80 will give you a sum of 171.8. And then we just found time from using our online quadratic solver. That time is going to be 8.13 seconds. And then if you simplify that, you'll get an average speed of 21.13 meters per second. And here, average speed is a scalar, so I don't need any directions, okay? So that's how I would find t personally. However, if you don't have a quadratic solver in your calculator, you'll have to just kind of crank it out old school or long way. Now, I want to remind you that in one of the parts earlier, we found the time that it took already to get from start to the peak, okay, from point A to point B, which is about 3.06 seconds. But then at point B, it stops and then it falls back down. So therefore, I already know part of the time. I already know the time up is 3.06. Now I need to find the time from the very, very top, point B, all the way down to the floor. And if I find that time, I can just add them up and that'll be the same value, okay? So here, I want to use my displacement function. I want to use my displacement function though from point B all the way down to the floor. So this is where you need to apply physics correctly, okay? These functions are super cool, except you just have to make sure you use it correctly. I want to apply this function from B all the way to the floor. Well, if I start at B, I know my VI is 0 because it was momentarily at stop at point B, okay? And then my delta Y is super easy to do. My delta Y is simply 45.9 plus 80 because watch my cursor. this is where point B is. This is where point B is. And then it's going to fall all the way down to the floor. Okay? Well, how far did it fall? Well, from here to here is 45.9. And then you're going to fall an additional 80. So how much did it fall? Just add those two values. So if you add those two values up, you should get a negative 125.9. And it's negative because I'm going from point B all the way down to the floor. And down would imply that this displacement is negative. And then here, I cross out VI because my initial velocity starts at point B now. So the time I'm finding is just the time down, okay, from the very, very top of the flight at point B. G, I know is negative 9.8. Here's my t squared, which is unknown. If I simplify this, 1/2 times negative 9.8 is negative 4.9. And then to get t squared by itself, I need to divide both sides by negative 4.9, which I will do. And then the negative signs here will cancel out. This is t squared though, okay? So if you simplify this on your calculator, 125.9 divided by 4.9, you get 25.7. However, to get t by itself, we need to take the square root of both sides, and this is where the radical sign comes in. Therefore, I kind of did two steps in one here, just to save some space. So if you square root 25.7, you get the time of 5.07. But it's important that you understand what this time is. Again, this time here is from point B all the way down to the floor. Well, if you watch my cursor, ready? From point A, or the top of the building, it took 3.06 seconds to get to point B, and then it took an additional, 5.07s to fall down and hit the floor. So if someone asks you how much time total, hopefully you can just use common sense and just go, well, my time total would just be the time up, which is 3.06, added to the time down, which is 5.07. Therefore, the total time is 8.13, which is what we got using our quadratic solver online. Okay, I like quadratic because it just crank it out super fast without doing all this tedious stuff, but you do you. Okay, other than that, I hope that helps. Stay nerdy, don't be whack.